restrictions. So if you would just draw a circle, we'll do it with a little diagram. If you'll draw a circle, when we're doing inverse sign problems, we are looking at only the right-hand side of the circle. So we're restricted on inverse sign, arc sign, however you want to say that. We can only answer with values on the right-hand side of the unit circle. When we do inverse cosine or arc cosine, which we're going to write as cosine to the -1, we are restricted to values at the top half of the unit circle. So we can only answer with values that are on the top half. And then one more, when we do inverse tangent or arctan and sine are the same. We can do the right-hand side of the circle. Probably should have put arc sine and arctan together. So inverse sine and inverse tangent, we're looking for anything on the right-hand side. And they even go a little bit further than that. They want you to use angles from this point right here, which they're going to say is pi/2, and this point right here, which they're going to say is -pi/2. They don't want you to use 3 pi/2. They want you to go from -pi/2 to +pi/2. That's the restriction for inverse sine. Same thing for tan. Inverse tan, you're going to go from +pi/2 to -pi/2. So we're going to be naming angles here from the unit circle. And then cosine goes from 0 to pi. So we have to know where our restrictions are. Alright, the first set of directions say find the exact value of each expression. Find the exact value of each expression. Anybody still copying? Alright, so this is the first time you've ever seen this symbol before. And it's inverse sine. And then there'll be a value after that. Okay, I might say arc sine. I might say inverse sine. But when you see the -1, this is what they're giving you. They're actually giving you the y value, because sine is y value, cosine is x value. So it doesn't say sine of an angle, it says inverse sine of square root of 3/2. So what this is this is a y value. Okay? Inverse sine says what angle has a y value of square root of 3/2. So that problem is saying what angle, that's what sine to the -1 means, inverse sine, arc sine, what angle in your restricted area from +pi/2 to -pi/2. So you're looking at your unit circle from +pi/2 to -pi/2. What angle has a y value, and I know it's a y value because it's inverse sine. What angle has a y value of square root of 3/2? How many? Yeah, let's practice radians here. You're right, pi/3. Okay? If our restrictions are pi/2 to -pi/2, then they want a radian answer for that. He said 60 degrees, and he's right, but they're wanting pi/3. Okay, let's try another one. And these don't have a lot of work. You just have to understand what they're asking you. So number 6 is another inverse sine. And this time it's negative square root of 3/2. So it says, what is the inverse sine of negative square root of 3/2? So that means what angle in the restricted area for inverse sine has a y value, because it's inverse sine, of negative square root of 3/2. Negative what? negative pi over 3 because you're rotating down here to the fourth quadrant. So you got to be careful when you see that -1, that's inverse sine. It's not sine. It means what angle has a sine value of. What angle has a sine value of. Let's look at a cosine one. Let's look at number 8. Inverse cosine. So already, as soon as you see cosine to the -1, that says what angle, that's what the negative means, what angle has a cosine value of square root of 2 over 2? Okay? Now, there's more than one angle that has an x value of square root of 2 over 2. So that's why there's a restricted area. And for cosine, your restricted area is from 0 to pi. That's why there's a restricted area, so you don't have more than one answer. So what angle has a cosine value that's an x value of square root of 2 over 2? Pi over 4. That's the answer. Okay? Inverse cosine means what angle has an x value of? What angle has an x value of? Number 10. Inverse cosine, negative square root of 3 over 2. Inverse cosine, negative square root of 3 over 2. In other words, what angle has a cosine value of negative square root of 3 over 2? Can't have negative pi over 6. It's not in our restricted area. It's got to be between 0 and pi. Five pi over 6. Okay? So if you're just sure you have the right angle that has a cosine value of negative square root of 3 over 2 and it's not in the back of the book, it's probably not in the restricted area. That's probably why you're missing it. Okay? So inverse cosine is the top half of the unit circle. Inverse sine and inverse tangent are the right-hand side, from pi over 2 to negative pi over 2. Any questions so far? All right, let's look at number 14. Inverse sine and inverse cosine are a little easier than inverse tan because inverse tan relies on y divided by x. So let's look at inverse tan. Let's look at 14. So inverse tan of 1. Inverse tan means what angle has a tangent value of 1. So you're thinking of y divided by x here, and tangent goes from positive pi over 2 to negative pi over 2. Pi over 4, he is correct. And once you get this, these are simple, but you have to understand what the symbols are asking you for. All right, this one will be a little bit harder. This is another tangent. Number 18, inverse tan. So that means what angle has a y divided by its x of negative square root of 3 over 3? What angle, this one's going to be a little bit harder. What angle has a y divided by its x between pi over 2 and negative pi over 2 of negative square root of 3 over 3? Negative pi over 6. Anybody want me to explain that? Alright, I want to take just a second to show you something. So if we just do the first quadrant of the unit circle, alright, let's talk about this point right here. What's the order pair of the point right in the middle? Square root of 2 over 2, square root of 2 over 2. What's the tangent value at that point? 1. Okay, that one's easy, right? So let's talk about this point. What's the order pair at this point? Square root of 3 over 2, comma, 1/2. So instead of having to think about this every single time, let's talk about what the tangent value is at square root of 3 over 2 and 1/2. All right, so the tangent value there would be 1/2 divided by or multiplied by 2 over, bless you, square root of 3. 2's will cancel. Then you're going to have to rationalize. So here, your tangent value is going to end up being square root of 3 over 3. Let's go ahead and just talk about this so we don't have to think about it. So when you're doing 1/2 divided by square root of 3 over 2, your tangent value is always either positive square root of 3 over 3, or if you were down here, negative square root of 3 over 3. So when you're doing 1/2 divided by the square root of 3 over 2, this is the tangent. So let's talk about that other point. What's the order pair for this other point? 1/2 comma what? All right, let's talk about the tangent here. So the tangent here is y divided by x, so that'd be square root of 3 over 2 divided by 1/2, or multiplied by 2 over 1. And so the tangent value at this point is just the square root of 3. So I really don't want you to have to every single time divide y by x. So the 45s, the tangent's either going to be positive 1 or negative 1. Okay? At the upper point, when you're dividing by 1/2, the tangent's either going to be positive square root of 3 or negative square root of 3, depending on what quadrant you're in. And then at that bottom point, when you're doing 1/2 divided by square root of 3 over 2, that tangent value is always square root of 3 over 3, positive or negative, depending on your quadrant. Okay? So I kind of like to go ahead and just talk about tangent because it's the harder out of inverse sine and inverse cosine. All right, so we did, what was the last one we did? 18. All right, questions about those? Those are the ones that you're going to be using your unit circle for. All right, next set of directions say use a calculator. You don't have to write this down. I'm just going to write it down. Use a calculator to find the value of each expression. Round to 2 decimal places. So we're going to use a calculator and we're going to round to 2 decimal places. All right, number 20. The reason we're having to use a calculator is you'll see when we write the first example, we're doing inverse sine of 0.47. Okay? So inverse sine means what angle has a y value of 0.47. Well, we haven't memorized any y values on the unit circle of 0.47, so it's one of those y values that we did not memorize. So this is where we have to use our calculator. Do you think we should be in degrees or do you think we should be in radians? Radians. What have we been in all these other problems? Radians. So we need to be in radians here. Okay? So make sure your calculator is in radians. You're in rad. And I'm in degrees. Let me swap real quick. Do you think you have an inverse sine on your scientific calculator? Yeah. Okay, where is it located? Above sine. Does everybody see sine to the negative 1 above sine? You actually have an inverse sine. To get it, you have to hit second sine, and then you're going to put in 0.47 radians, and you're going to hit equal, and it's telling you to round to 2 places, and this is actually an angle. It doesn't look like it is, but it is. It's 0.49 radians. We're doing the same thing, but we're doing it with values that we've not memorized. Okay? These are values that we have not memorized. Let's look at number 30. Number 30 says inverse tangent of, ooh, this is ugly, negative square root 5,000 61. Who sits around and makes these problems up? All right. Would we have a tangent value of that on the unit circle? No, our tangent values are things like 1 and -1 and square root of 3, negative square root of 3, and undefined and 0. So that's why we have to use our calculator here. So we do second tan, brings up inverse tan. We put in that really ugly square root. We round to 2 places and we get what? 1.56. Someone shouted from the crowd. Not. Did I get negative? Oh, look, it's negative. I just didn't write it down. You're right. I'm wrong. Alright, so there'll be a little section that says use a calculator to find the value of each expression, round to 2 decimal places. And you need to make sure here that your calculator is in radians, because we're doing all this section in radians. Alright, fixing to change directions again. Everybody good? Alright, next set of directions are going to say find the exact value of each expression, if possible. Do not use a calculator. Find the exact value if possible. Find the exact value if possible. Do not use a calculator. What do y'all think that means, find the exact value if possible? So maybe we might have a problem that's undefined. Alright, so let's look at number 32. Number 32 says cosine, just regular old cosine. Okay, please tell me that you're not going to forget what cosine means. Cosine means what? What's the x value of the angle? Just regular old cosine means what's the x value of the angle. Alright? And then in parentheses, there's an inverse cosine, which means what angle has the cosine value of. And then there's a radian measure. Alright, I'm just going to tell you what the answer to this one is and let you kind of think about it. Got any thoughts? Besides, this is stupid, why am I learning it? Okay, Major says those cosines are going to cancel out. They're going to cancel out because one's cosine and one is inverse cosine, but you have to get something that's in your restricted value. So where's cosine restricted? On the top from 0 to pi. What's pi as a decimal? Just estimate. 3.14. So would 0.57 be in the top there? Would it be in our restricted value? Yeah. Okay, so that's our answer. You could just cancel those out as long as that value is in your restricted value. You have inverse cosine anywhere in your problem. All right, let's look at number 36. Alright, so 36 says it starts off with inverse cosine, and then it has cosine 4 pi over 3. So again, inverse cosine and cosine will cancel each other out, but your answer has to be something in the restricted value for cosine, which is between 0 and pi. So if these cancel each other out and you say 4 pi over 3, are you in this restricted area? No. Okay, where are you if you're at 4 pi over 3? You're in quadrant 3, and you are right here. Okay? So you can't answer 4 pi over 3, but you can give me another angle that has the same cosine value that is in the yellow restricted area. 2 pi over 3. Does everybody agree that 2 pi over 3 would have the same x value? So we can't use 4 pi over 3. We're going to have to use 2 pi over 3 because we have to be in the restricted area there. So you might want to write yourself a note. We have to be between, maybe just put 0 and pi. So you can cancel all of these out, but you just have to make sure that your answer is in the restricted area. You can cancel them all out. You just have to make sure that your answer is in the restricted area. Alright, 46 will be the last one that I do in this set of directions. So we have inverse cosine, and then this is not a typo, it's inverse cosine again, and then it's 3 pi. So it really doesn't matter this inverse cosine. It could be anything. I want you to focus on this 3 pi. What does that 3 pi mean? Just look at this part of the problem. What's that 3 pi mean? Inverse cosine of 3 pi. What's inverse cosine mean? What angle, inverse cosine means what angle has what kind of value? X value of 3 pi. What angle do you know of that has an x value of 3 pi? Well, angles don't have x values of 3 pi. 3 pi is not an x value, it is an angle. So this is one of those that you can't determine, and they just write not defined. It's not really got anything to do with the inverse cosines. It's the fact that this 3 pi is not an x value. Okay? It's not an x value. So every once in a while they're going to throw something in that just doesn't make any sense at all. And that's why it says find the exact value of each expression if possible. Alright, your next set of problems are going to say, use a sketch to find each value. Use a sketch to find each value. Use a sketch. So number 48 says sine. This is just regular sine, not inverse sine. And then it has inverse tan, 7 over 24. Okay, so this won't be like the previous set of problems. You can't cancel sine and inverse tan out. That's not going to happen. So you're going to start with your middle part. You're going to start with this part, the inner part. And this says what angle has a tangent value of 7 over 24? So is 7/24 a tangent value on the unit circle? No, there's no y divided by x's on your unit circle. So this must be coming from another circle that's not a unit circle. So this is giving me some values. It's giving me x, y, and r. So what do I know if they give me tangent? You know x and y. Okay. You know that x is 24 and y is 7. Okay. Do y'all know whether x is positive or negative, or whether y is positive or negative? Where is inverse tan restricted? To the right. Does everybody agree with that? Inverse tan is restricted to the right. So tell me about x x values on the right of the circle? They're always positive, okay? So if my x value is positive and my tan is positive, what does that mean about my y value? It's positive also. So you're going to have to maybe make a sketch, think about where your restricted areas are, and that will affect whether your x's and your y's are positive or negative. So tangent, inverse tangent, always has x values that are positive. So if my whole tangent value is positive and x has to be positive, y has to be positive also. All right, we need to find the r because they're asking me for the sine at this same angle. And sine is going to be y over r, okay? Then you go and you find the sine of that same angle. So has somebody done 24 squared plus 7 squared equals r squared yet?
Yeah. 25.
And for r, you got 25?
Yes, ma'am.
All right, so now they're asking you for the sine value, not inverse sine, but what is the sine value at that same angle? So sine is y over r, and that would be 7 over 25. These will be the harder problems. All right, I got 3 more examples. Let's see if I can get them in. Number 56. 56 says secant, bracket, inverse sine, negative 1/2. Close bracket. All right, so you're going to go over to the right. You're going to do that first. Inverse sine. Which part of the circle are we looking at for inverse sine? The right-hand side. So this says what angle has a sine value of negative 1/2? What angle has a sine value of negative 1/2? Negative pi over 6. Y'all agree with that? So we just answered this part first. And then it says, what is the secant value? What is the secant value at negative pi over 6? So remember, secant is the reciprocal of cosine. So what's the ordered pair at negative pi over 6? Let's talk about that. What's the ordered pair at negative pi over 6? Negative square root 3 over 2, 1/2. Alright, so they want to know the secant value. And secant is going to be, are y'all sure about that? Is that the right order pair? Do what? Negative 1/2. Alright, so the secant value would be the reciprocal of x. Alright, so the reciprocal of that would be negative 2 over square root 3. Secant is the reciprocal of x. I think I've lost y'all. Rationalize, and you're going to get negative 2 square root 3 over 3. Something's not right. It is positive. That's positive, right? This is positive. It's positive. Positive. Is that what you were asking? Yeah. Okay. So you may have trouble as you get into these harder problems, but just take this value, find it first, and then you'll find the secant of that value. Secant is the reciprocal of cosine, so you're going to do 1 over x. All right, I got a couple minutes. I'm going to stop. The only problems I didn't get to do were 60 and 62. They're worked like 56, so I think that'll be enough examples for